because there's other stuff going on in our solving absolute value equations. We still have the same goal today. I can solve equations in one variable with absolute value expressions, but we have to add to that goal. We have to know how to set them up also. So we need to know how to set up absolute value equations along with being able to solve them. Okay, so today we're going to move into, there are some special cases of absolute value equations. So solve negative 8 equals the absolute value of x plus 2, subtract from that 8. Okay, so we're going to use the same process we did yesterday. That's not changing. Same process, so we're going to think to ourselves, do I need to do step A? Like, yeah, what are we going to do? We're going to add 8 to get that subtract 8 that's outside the absolute value bars. Add 8, okay. So now we have, what do we have on the left side? 0. Is 0 legitimate? Yeah, it's a number on the number line. It's okay to have 0. Even though sometimes we panic and think we shouldn't. Okay, do we need to do any more steps in step 8? Is our absolute value expression isolated? Are we ready to move on to step B, or do we have another thing to do? Help me.
We have to get the x alone.
We have to get the x alone, but right now, but we're not trying to get x alone, we're trying to get the what alone? The absolute value expression, right? That's what we're trying to get alone. Is it alone? Yeah, it's alone on the right side, isn't it? Nothing's happening outside of it. Okay, so we are ready to move on to step B, and step B says, set up there's 2 cases. Okay, well, that means we're going to take the expression x plus 2, we're going to ditch the absolute value bars, and we're going to set it equal to the numbers that have a distance of 0. So we have x plus 2 equals 0, and what would the other one be? What other number has an absolute value, has a distance of 0? Nothing. There's only one number on the number line that's 0 units away from itself. It is 0. It's itself. So this is why it's called a special case. We can only set up one case. Only one case this time. Even though some of you tried to make a lot of the other ones into one case, they weren't. They're only one case when it turns out that the constant on the other side, once the absolute value expression is isolated, once the constant on the other side is 0, there's only one number on the number line that's 0, has 0 units of distance from 0. That's 0 itself. Okay, so now we're ready to move into, yesterday we didn't identify it this way, but let's do it starting today. C. Step C is solve it. So what are we going to do to solve this? Subtract 2. From both sides, and we will have our one and only solution this time. It is negative 2. In other words, it's the only solution, the only number that would make that equation true. Okay, how can we make sure it's a solution? Aiden, what would we do? Blake? Plug negative 2 in for x and see if it makes the equation true. So let's go back up here to the beginning. What's negative 2 plus 2? So we're substituting it in here. What's negative 2 plus 2? 0. What's the absolute value of 0? 0. It's 0 units of distance from itself. What's 0 take away 8? Negative 8. What's on the other side? Negative 8. Checks out. Can you think of any other number that if you added it to 2 and then took its absolute value and then subtracted 8, we could get negative 8? Or in other words, is there any other number that if you subtract 8 from it, you will get negative 8 other than 0? There's none. So this is, we call it a special case because there's only one solution. So let's write that too. Only one solution. Now, that doesn't mean I get to say brain, Today there's this new thing, there's only one solution, so that gets to be my new way. All of them are going to have one solution. When do we think we can say to ourselves, this is when I'm only going to have one solution? When do you think it's going to happen?
Only when the distance is
Yeah. So only when the absolute value of expression, once it's isolated, is set equal to 0. Yeah, when it's set equal to 0, after it's isolated, then there's only going to be the one solution, only one case to set up. Okay, you go ahead and solve this next one. Try solving this next one. See what happens here. Do it in your steps, A, B, C, if you... Make sure that you make those absolute value bars long enough so they don't look like ones. Sometimes they get mixed up with ones because we don't make them long enough, high enough, low enough. Okay, you should be done. You may know why we should be done. Okay, that's all I've done. You should be done now too. Why? I have the absolute value expression isolated. And this would be where we would say to ourselves, I need to set up the part B where I dish the absolute value bars. I have to be able to set the expression x plus 4 equal to the numbers that have a distance of -2. Do we know any numbers that have a distance of -2? No, we don't talk. Remember we talked about that yesterday. We don't talk about numbers having negative or a distance as negative. Distance is not negative. Distance is always positive. So we can try all day to try and solve this and think that we came up with a solution. Did anybody, by the way, get a solution or two? Let's go ahead. Did you, Brendan? What did you get? -6 and -2. Okay, so let's just remember how we said we can check to see if our answers check out. So -6 put in here. -6 plus 4 is -2. What is the absolute value of -2? What is the? Because we put -6 in, add 4 to it. We get -2, so now we have the absolute value of -2. What is that? What is the absolute value of -2? What? You don't know? It's 2, isn't it? Isn't -2 2 units of distance from 0? Well, then we'd have 3 plus 2. What's 3 plus 2? What's 3 plus 2? 5. 5. We'd have 5 on that side and we'd have 1 on the other. Does it check out? No, it doesn't check out. Okay, well, ditch that one. Let's try -2 then. -2 plus 4 is 2. What's the absolute value of 2? No. What's the absolute value of 2? It's 2, isn't it? And what's 2 plus 3? 5 again. Is 5 the same as 1? No, we're going to ditch that solution too. So see, even though we think we can solve it, we really can't. Because here's the reason it breaks down right here. We cannot have negative distance. These absolute value bars over here say distance. The distance of whatever's inside there. We don't even care what's in there right now. The distance of whatever is inside there has to be a -2. So this one we say, we can't even do it in step B. If we try to do it, we say can't have negative distance even though we might want to try. Step B, can't have negative distance. So step C, what's our solution? No solution. This is not, does not have a solution. So no solution is our solution.
So technically you have a solution.
We have a solution, but we call it an empty set. Yeah. Remember the mathematical symbol for this? How's it go?
0.
0 with, yeah, like that? Yeah, that's empty set, in other words. There's nothing in it, nothing's gonna satisfy this. Okay, so add it to it. I'm not saying that all your problems are gonna be like this today. Now we have to start thinking like this also. Sometimes we're gonna have 2 solutions. We're gonna be able to set up 2 cases. Sometimes we're gonna have 1 solution. We're only gonna be able to set up 1 case. And sometimes there's gonna be no solution because we're gonna get to that step B and we're gonna see that the absolute value expression isolated is set equal to a negative number. Now don't be fooled by this. Don't be fooled into thinking that if the equation starts out set equal to a negative number, that means you're going to have no solution. Because look at the first one we did. It is set equal to a negative number right here, but we got a solution, didn't we? We got to wait until the absolute value expression is isolated and then make that decision. So what are all the possibilities for solutions again? How many? What are the possibilities? 2 solutions? 1 solution? No solution. Okay. And so you're gonna have to be looking to see which situation. Okay, now let's learn how to set up our own. Write and solve an absolute value equation to find the following. We have this thermostat that is set so that the temperature in a laboratory freezer stays within 2.5 degrees Fahrenheit of 2 degrees Fahrenheit. So what's that really saying? So what's the ideal? What do they really want the temperature to be at? 2 degrees Fahrenheit, right? But they're willing to what? Let it go 2.5 degrees lower, let it go 2.5 degrees higher, right? It says within 2.5 degrees. So it can vary from 2 degrees Fahrenheit, it can go 2.5 degrees that way, it can go 2.5 degrees this way. So I'm going to guess without even setting up an equation, you'd be able to tell me what the answers to this one are, right? Find the maximum and minimum temperatures and graph them. Okay, well, right now it looks like 2 is, I've done the graphing, and it looks like I've already figured out that if you go 1, 2.5, here would be one of your solutions, right? And if you go 2.5 the other direction, here would be your other solution. That's how we graph them. We have to identify where we're at on the number line. We plot points on it. Okay. Well, I often tell students that it helps if you do draw the graph, even before you start sometimes, because then it helps you decide how to set up the equation. Because when we're going to set up an equation, we want to know what's the ideal, what's the middle value, what do we really want it to be. Just like yesterday in the game contestant thing, what was the actual cost of the DVD player? What was the actual cost? If we guessed it right, what was it? Does anybody remember? $169. That would have been what we call the middle, the ideal, what it really actually is supposed to be. Then their guesses were how much it varied by. Okay. So what's the middle value we're starting point in this one? 2. Yeah, 2 is. What's the distance that it can vary by? 2.5. Okay. So here's a model right here. This is the model for setting up, and this is, memorize it. This is how you will set up your absolute value equations. You will subtract the middle from x. That's what's going to be your absolute value expression. And you're going to set it equal to the distance, or in other words, how much can it vary by. Okay, so anybody want to offer up what they think might be the equation for this one? Tyler? X minus 2 equals 2.5, 2.5. Okay, you guys agree? Good equation? Okay, let's solve it now then. Let's see if we get the 2 points that we plotted on that number line. So, do we need to do step A? No, we don't really need to do step A. It's already isolated, so let's move on to step B. And step B, what do we do in that step? take out the absolute value bars and set it, the expression inside equal to the two numbers that have a distance of 2.5. So we have x minus 2 can be set equal to 2.5, and x minus 2 can be set equal to negative 2.5. And notice we can use the negative because negative 2.5 has a distance of 2.5. The absolute value bars aren't there anymore. We're not referring to distance anymore. And now we should be able to solve both cases. And this one's going to get the 4.5. And the other one gets us the negative 0.5. So it says find the maximum and minimum temperatures and graph them. Well, we did the graph first, just so we could see what we should get, because it was a fairly easy problem. And then we came back and did it. So what are we going to label these? 4.5 degrees Fahrenheit. Yeah, we measure in Fahrenheit. And is this the maximum or the minimum? This one's the max. Okay, we'll just call it the max. Okay. And the other one, same label, but this one is the minimum. Okay. So we need to identify that because that's what they wanted us to find. Okay. Okay, anybody have questions about that one before we head to the back side? Okay, hearing none, I'm going to move to back. Looks like we need to be on page 57. We're going to practice some problems that are in our book. I guess you probably have some problems like this doing your homework then. Number 13. Okay, read that problem to yourself. A number line there, or the start of a number line anyway, for us to kind of like, make a picture of what's going on here. So, anybody know where on the number line we should be? Like, do we have a middle value? What's our middle value? 207, okay. So, I'm just going to put 207 in the middle here. Okay. What else what's the distance that it can vary by? 2, okay. So if it can vary by 2, I'm going to go 2 tick marks over, and that would be 209 this way, and this way it would be 205, right? Yeah, remember, make good number lines. Don't be just you don't have to get out a ruler and measure, but eyeball it pretty good. Okay. We're supposed to find the minimum and the maximum mile marker for 207 that Barry's walkie-talkie can reach. And it says what we have to do is write and solve an absolute value equation. Well, it looks like our solution should be what, according to what we just did with this number line? What should our solutions turn out to be? 205 and 209. So it doesn't say we have to graph. We're just doing that to make sure that we learn how to be successful with these. It doesn't say you have to graph. You don't have to, but okay, so let's set up our absolute value equation. So, anybody want to offer up what they think would be a good equation for this one? Blake.
X plus 207. Yeah.
So, absolute value around that?
Yeah.
Okay.
Equals to.
And you all agree? Let's look at our model on the front. What did we say was going to be our model we were going to use? We're going to use what instead of addition? We're going to use subtraction, yeah. Because what we are really trying to do is find the difference, and so it turns out to be the subtraction is what we should be using. So we're going to change that to subtraction in there. Okay, and then we're going to get ready to get it. You do it, solve it now. Do we need to do step A? No. The x minus 207, the absolute value, that's already in isolated I mean, so we can just set up our, how many cases? It's set equal to a positive number, so there'll be 2 cases. X take away 207 equals 2, and X take away 207 equals negative 2. So notice what's kind of happening here. It says we're going to go 2 in the positive direction from the middle, and we're going to go 2 in the negative direction from the middle, and that should help us get our answers, really. So we'll now solve. We'll do step C, which says solve for X. And this one, the first one gives us the 209, and the other one gives us the 205. So even, some of you are going to, here's what's going to happen with these problems. Some of you are going to be able to come up with the answer because you'll be like, this is so easy. I can do it without the absolute value equation. And that's cool. But if they tell you you have to write and solve an absolute value equation to get the answers, then that's what you're getting assessed on. That's what they want to make sure you know how to do. So we did get what our graph showed us, but we probably had already figured out were the answers. Minimum mile marker is 205, and the maximum is 209. Okay. These are mile markers, so we don't necessarily put the label miles or whatever. You familiar with what those look like on the highway? You seen those? Yeah. Okay. So the other thing we have to do is sometimes they'll just give us the solutions graphed on a number line, and we have to go from there to getting what was the absolute value equation this represents. So here we have, write an absolute value equation whose solutions are graphed on the number line. So what are the solutions? What is this showing? Okay, so -5, so let's just write that. Solutions are -5 and 1, right? Okay. So we have 2 solutions. We have to write an absolute value equation that would actually, when we solved it, it would give us those 2 solutions. Okay? So I tell you, it would be a good idea to determine the middle value and the distance since our model requires both of those. So what's the middle value? -2. If we work our way in like this, we can see that we're going to end up at -2 being our middle value. The distance that we had to go from both solutions to get to that middle is what? 3. We went 3 in on both to get to -2, okay? Write the equation. Solve your equation. See if you get those 2 solutions, -5 and 1, with your equation that you set up. Were you successful? Sometimes we're subtracting a negative number instead of a positive number. So we have to substitute. This stays subtraction. Notice I didn't change that subtraction. I left it subtraction in my model. I put in the middle number. I subtracted the middle number. Then I went over and cleaned it up. I said, oh, x subtract -2 is the same as x plus 2, the opposite of -2. And then I went to work solving it from there. So if you were successful at that, you might want to get that cleaned up in your notes. So what our equation, and this is how we would see the answer in an answer bank. Cleaned up. So if you're told to write, here's our equation right here. If you are told to write an absolute value equation to represent the solutions, you want to make sure you clean it up also. So we would not see x minus on a negative 2 absolute value bars around equals 3 in the answer bank. We would see it cleaned up. The absolute value of x plus 2 equals 3. Any questions, any part you're still not sure about? Okay, then let's get on your loose leaf paper and very carefully write down what the assignment is because it's kind of a crazy mix of problems there.